Now we've already seen that butterflies and moths perceive their world in a completely different way to how we do. And although vision is their primary sense, there are a whole load of other senses which we're only just beginning to understand. I'm about to meet with electrical ecologist Sam England, who may not be able to fix your fuse box, but should be able to tell us about how butterflies and moths use electricity in their day-to-day lives. That's a toilet, sorry. Here's the lab. Oh, hi Sam, how are you?
Hello, what do you want?
So Sam, because it's something we can't perceive, I guess ElectroReception might seem quite sci-fi to a lot of people, but lots of other animals are able to perceive electric fields, right? Do you want to explain a little bit about how that works?
Yeah, sure. So something that we're kind of maybe all aware of is that there's this thing called static charge, right? This is the thing that you experience when you rub a balloon on your head or you're bouncing on a trampoline and you get a static shock. These static charges produce electric fields, and these electric fields can exert forces on other static charges. Now, something that people maybe won't be aware of is the fact that a lot of animals and plants in nature are actually sources of charge and so produce these electric fields. And what I'm really interested in looking at is basically whether these electric fields can have ecological consequences for these animals and plants. Can they help or hinder them as they live their everyday lives?
That's really cool. So why are butterflies and moths such useful animals to work with then?
Yeah, I mean, so there's a couple of reasons for that, but I think first and foremost for me, I think what's really great about butterflies and moths is that they're essentially 2 for 1 in terms of a study organism, because you can do experiments on the caterpillar stage of them, you know, doing experiments on whether they can, say, detect the static charge of their own predators. But then when you raise them into adulthood and they become butterflies or moths, you can do experiments on completely different ecological contexts, like pollination, or for example, if a butterfly or a moth is approaching a flower to feed from it, could predators waiting on the flower, like a crab spider, detect the moth or the butterfly coming by that static electric field?
That's really, really cool, because I guess if all animals are to some degree electrically charged, and that's quite an unavoidable cue that a predator could use to detect its prey, right? You've got this rather sciencey looking piece of apparatus here, and I believe this is what you use for some of your experiments to test your hypotheses, right? Do you want to explain a little bit about how it works?
Sure thing. So basically the setup for this experiment is a behavioural one. So what we're doing here is we're playing the electrical signal that we expect to come off a statically charged wasp, which would be a predator for a caterpillar like this. And we play these wasp electrical signals through this metal electrode here, which is kind of acting like an electrical speaker. So it's kind of, instead of making sound, it's making electricity. Right. And then we watch what the caterpillars do in response to these signals, and we look for behaviours like flailing or trying to bite the electrode that might indicate that the caterpillar is perceiving this electrical signal as a threat.
Right, wow, well, really advanced setup, Sam, I've got to say. It's a shame it's not plugged in though, isn't it?
Get out.
Okay. Well, there you have it. From long distance migrations to super sensors, from the evolution of group living to the evolution of elderliness, butterflies and moths provide so much opportunity for exploration and discovery, enhancing our understanding of ecology and evolution as a whole. And the amazing team of scientists and the advanced facilities here at Bristol are playing a world-leading role in making those discoveries happen. All very high-tech, and as you can see, not a butterfly net to be seen.
Oh, Mr. Daniel.